Welcome everyone. This is the first lesson recording for IM2, November 5th, 2020. Some announcements. First, we are going to have quiz number 5 next class. It's going to be on simplifying square roots, Pythagorean theorem, and calculating for special right triangle. So you really need to be very comfortable with homework number 18, 19, and 20. So I am quickly going to go over the answers to homework number 18, 19, and 20. So here are the answers to homework number 18. And here is my number 20. And this is my homework number 20. Okay, the first thing you should do is draw your most basic 45, 45, 90-degree triangle with side length of leg having 1, 1, root 2 as hypotenuse, and also the 30, 60, 90-degree triangle with the short leg having the side length of 1, the hypotenuse having the side length of 2, and the longer leg having the hypotenuse of 3. So that way you can figure out what is the relationship. And here are the answers. Okay, so let's get into the lesson today. What are we doing today? We are going to go into side ratios of not so special right triangles. So before we do that, I want to explore the word adjacent and opposite in English language. So when you hear adjacent, what are you thinking of? So this is a map of different stores. This is made up. Okay, so if I was to ask you, name the store adjacent to Safeway. Okay, I want you to think about what do you think I mean when I say adjacent to Safeway. So think inside, what do you think is the store that is adjacent to Safeway? Hopefully you're telling me it's In-N-Out Burger. So when we say adjacent in English, we're talking about next to. All right, then what is the store that is opposite the Safeway? Opposite, when we're talking about opposite, we're talking about across from, right? So in this case, you could say McDonald's or Starbucks. Well, McDonald's is directly opposite. Starbucks is a little bit more on the diagonal. Okay, so if I was to ask you, name the store adjacent to Starbucks. Okay, now we're speaking in terms of Starbucks now. That's the reference. Which is the store adjacent to Starbucks? We're talking right next to Starbucks, so it's McDonald's. And what about the store opposite the Starbucks? That would be Safeway and In-N-Out Burgers. Okay, so think about how you use the word adjacent and opposite. So adjacent really means not across from. I'm sorry, this is a typo. This is opposite, and oh, I need to fix this. Okay, so I just fixed the slides. Okay, so when we say adjacent in English, we really mean next to. And when we say opposite, something is opposite, we mean across from. Okay, so when we're talking about angles, when we're referencing legs in a right triangle, legs can be opposite or adjacent to a reference angle. So in this case, depending on whether we're talking in terms of 67 degrees angle or the 23-degree angle, what is the leg that is opposite and adjacent will change. So for example, if you're using 67 degrees as the reference angle, so that means we are looking from the perspective of 67 degrees. So from 67 degrees, the opposite leg, that means opposite means across from this angle. So here is my angle. Across from is going from across is the leg is the W. In contrast, from the angle 67 adjacent leg, that means the leg that is right next to. Okay, what is the leg that is right next to? Is the leg that's V. U is the hypotenuse, so it's not a leg. It's neither opposite or it's not neither adjacent. It's just hypotenuse. But if you're using 23 as the reference angle, that means from us we're looking from the perspective of 23 degrees angle. Okay, so when we're looking from this angle, which is the opposite? Opposite means across from. So across from this 23 angle is this one. So which is the leg V, while as the adjacent to 23-degree angle is, that means right next to this angle, the leg that is next to the 23 degrees angle is the side length W, or the leg W. U again is still the hypotenuse, because hypotenuse is the side that is opposite the right angle. All right, so I want you to go on to Desmond's exercise, card number 1 to 4. Please freeze the video and do those now. Okay, so that was a quick exercise on identifying adjacent and opposite and hypotenuse of right angle triangle. So let's do a quick detour of Greek alphabets. So far, you've already used some of them. Pi is a Greek alphabet. It's a magic circle ratio that you've already dealt with a lot. Okay, so it's a ratio of circumference over the diameter of any given circle. And that's known as 3.14159, so dot, dot, dot. This triangle, it's pronounced delta, and it is used to denote difference or change. So pi and delta, they're both Greek alphabets that you've already come across in math already. When do we use that? When we're talking about slope, we said the slope is delta y over delta x, or sometimes we will use change in y over change in x to talk about the slope here. Okay, so we're going to introduce another one. This is called theta. It looks like a zero with a line across in the middle. It's pronounced theta. It's a common variable denoting unknown angle measure. So when we do not know the angle measure, we often use the Greek letter theta. Okay, so we have this side lengths 20 and 50, and we do not know the angle. That's what it means. Okay, so before we go on to anything, I want to show you how you should memorize the 30, 60, 90 degree and 40, 45, 90 degree triangle ratio. There will be very few things that I am going to ask you to memorize from math, okay? Contrary to what a lot of people think. Math does not have too many formulas that you do need to memorize. There are few, but more importantly, that you need to know how to use them correctly. But just like knowing multiplication facts will help you do math so much more efficiently. Memorizing this 30, 60, 90 degree triangle ratio and 45, 45, 90 degree triangle ratio, it's going to come handy not just for now, but many years to come as you go deeper into trigonometry. Okay, so the first thing I'm going to do is do 45, 45, 90 degree triangle. Okay, to do that, I am going to draw a right angle triangle that is isosceles. Okay, so this will be same side length. And when you're drawing this triangle, draw it sort of approximately like it looks like they're the same. Okay, same side length. And you're going to label that as 1 unit, 1 unit. If this is 1 unit long and this is 1 unit long, what is the hypotenuse? It's going to be 1 squared plus 1 squared, which is 1 plus 1, 2, 2 square root of 2, right? This is using Pythagorean theorem. Okay, so if this is 1 unit, the other leg is 1 unit, the hypotenuse is going to be square root of 2. So, and then you are going to draw another triangle, and this time, again, I wanted you to draw approximately so that it does not look like isosceles triangle, but when you draw one, this has the measure of 1 unit and the hypotenuse has 2 units, and if leg is 1 unit and hypotenuse is 2 units, then the other leg, the long leg, has to be square root of 3 units, because 1 squared, which is 1, plus square root of 3 squared, which is 3, has to be equal to square of 2. And that's just using Pythagorean theorem. And so happens that this, and you can tell which is the bigger angle. You can tell just by visually, this looks bigger. So this has to be the 60-degree angle, and this has to be the 30-degree angle. And this is always, of course, the right angle. Okay, so these are the two triangles that you're going to draw over and over again when you are solving right angle triangle problems. Okay, and the way you memorize it is every time you are solving those problems, you just draw this. This is the tip that my teacher taught me about 35 years ago. And believe me, it really does work. You don't have to do anything other than just 1, 1, root 2, and then draw 1 to root 3 approximately to the right ratio. And then you can clearly see which is the smaller angle. The smaller angle is going to be 30. The bigger angle, that's going to be 60. Okay, so then how do I use this? Well, I know that going from the leg to hypotenuse is going to be multiplied by root 2, which means going from the hypotenuse to the leg of 45, 45, 90-degree triangle, you're going to divide by root 2, okay? And then from this, you can tell that from the short leg to the hypotenuse is going to be multiplied by 2, and short leg to the long leg is going to be multiplying by root 3. That's how you use these triangles once you've drawn them. So on tests and quizzes, what I ask my students to do is, once you've memorized this, the first thing you do is on top of your paper, you draw this, okay, so that you can use it correctly and that you do not get them mixed up. Okay, so now I would like you to tell me in private chat, what is the length of leg X? Okay, so first thing you should be identifying is what sort of triangle is this? This is 30, 60, 90-degree triangle. Okay, so what is the relationship between, this is the short leg to the hypotenuse. The short leg to hypotenuse, short leg multiplied by 2 is hypotenuse. That means hypotenuse to short leg is going to be divided by 2. So the X has to be 12 divided by 2, which is 6. Okay, what about this leg of X? Okay, so remember, from the triangle that I have just shown you, to go for 45, 45, 90 degrees triangle, first identify that, the leg to the hypotenuse is multiplied by square root of 2. So that means going from hypotenuse to the leg, you need to divide by square root of 2. So 18 divided by square root of 2 is 9 root 2 when you rationalize the denominator. All right, then what about this? What is the length of leg X? Okay, so what sort of triangle is this? This is 50, 40, 90-degree triangle. Do we know anything about those ratios? Not yet. Okay, however, if you know this triangle, these two triangles are similar, aren't they? Okay, so this is 50-degree triangle, this is 50-degree triangle there, and there's 90, 90. So that means by angle similarity, these two triangles are similar. So we can use the ratios within the shape to figure out. Okay, so now you are going to use decimals, cut number 5 to 9 to explore this.